One way to avoid co-channel and adjacent channel interference is a proper channel reuse design, which is very necessary in the Wi-Fi world. So if we want to get rid of, or try to get rid of the ACI and the CCI, that is CCI and ACI, we need to have a good channel reuse design, which is also known as a multi-channel architecture, right? So we need to make sure we have overlapping RF coverage cells. Of course, we need that for roaming to happen, but we want to make sure that there are no overlapping frequencies used. This should not be done, and overlapping coverage cells, yes, they should be used. Okay, so if we have overlapping frequency, then we're going to run into a problem of, again, CCI and ACI. That is something which we want to avoid. So a good multi-channel architecture or a channel reuse plan they need to be employed, or on the Wi-Fi network, to make sure that that doesn't run into a problem. The limitation is that in 2.4 we only have 1, 6 and 11 channels that meet this criteria of non-overlapping frequencies, right? In 5 gigahertz, yes, we have around 24 channels if everything is available. Total 3 here, total 24, and all are non-overlapping, right? Which is a good thing. So 5 gigahertz is not a problem, but 2.4 gigahertz kind of become a problem when using a channel reuse plan, because we only have 3 channels that meet that criteria of channel of non-overlapping frequency, right? So having said that, I'm going to quickly give you an idea as to what I mean by drawing a picture of how channels are used in the Wi-Fi design. Let's do this. This is, let's say, 1. This is, or let's make that 11. Let's make that 6. Then again, let's do this. Right, so we'll make this 1, 11 and 6. So like this, you make a channel schema in the Wi-Fi world. This becomes 6 and 1 and so forth. That's you get the idea, right? So that's how you design a network, and this is how the APs, when connected on the Wi-Fi in network, should use the channel reuse plan, so that channel number 1 and channel number 1 here are very far away, so that they are not able to hear each other all the time. Now, having said that, I'll be very honest with you that it is practically impossible to avoid any instance or all instances of CCI and ACI. Okay, it's very difficult. So practically impossible to avoid CCI in the network. It is not gonna happen, right? I'll tell you why. There'll always be a certain bleed of the frequencies. So you'll always have the frequency of channel number 1 bleeding over to this channel of the same working on the same channel on the AP, right? So let's give you an example. Let me kind of simplify this a bit now for you. Okay, so this is 1, this is 11, this is 6. Now what we did was we did this as channel number 1, which is definitely away. However, if we have a client right at the corner of this particular cell communicating with the access point here, there'll always be some sort of a bleed in this AP's coverage cell also. Now that means on a single frequency, if this client is transmitting and he is also heard in this BSS, then nobody in this BSS can also transmit data. That is what CCI is, right? Co-channel interference. You'll have so in one frequency range, only one radio can transmit at a time. That's pretty much how CSMSCA is defined. This is CSMSCA is defined. This is what half duplex means. So it's practically impossible. There'll always be some sort of a bleed happening between the APs on the same channel, and that's going to prevent the radios to work as they should work, and also going to cause some sort of an CCI there, right? Now, since there, I mean, this is only happening because there are only three channels available, right? 1, 6, and 11. If there were more channels like 5 gigahertz, then we can have all the range that we need to basically work with 36, 40, 44, 48, 52, so on, 52, so on and so forth, 100, 104. All those things can be used, and then we can actually have more channels, and the channel schema can be a lot better. We can in a way avoid CCI in 5 gigahertz, where it's very difficult to do that in 2.4 gigahertz. 2.4 is practically impossible to do, right? So nowadays also in networks we have networks that support 2.4, and that's the reason why this is always going to be there. We can't get rid of that at all. Okay, now another thing that you should know is, which is not usually discussed in a lot of places. Now you've done a design, you use 1611, and usually RRM can take care of a lot of things. However, when you do, let's say you are given a building to perform a site survey, okay. Now I'm going to give you a picture of a 3D model, okay. So let's say this is floor number, let's make some floors here. I'm going to make one more floor so that, yeah, this is floor number 1. This is floor number 2, this is floor number 3, this is floor number 4, and this is floor number 5, okay. Now when you do a design, of course you do one floor, you get an access point right here, access point right here, access point right here. You say, yeah, it's going to be 1, 6, and 11. Life is good. Now what you do is you replicate the plan for other floors also, because the other floors are very identical, and you tell them that yes, go ahead and deploy the APs in this manner and on these channels. That's a very big blunder. Why? Because if you do this again, 1, 6, 11, again 1, 6, 11, that's a problem, because you can expect the AP on this ceiling here to have some sort of a bleed in between the floors and reach here as well. Similarly for this AP and for this AP also. Now what you need to do is, you want to make sure, we don't know how the floor is really, what kind of material there is on the floor and the ceiling of this particular floor, so we can't take a chance. And the coverage bleed between these two floors is also not too much, so that clients on this floor can connect happily on the AP of this floor. That's also not true. So you dedicatedly need an access point on this floor number 4, and you also need access points on floor number 5. So you need to make sure when you do a site survey, you have to walk on this floor also and dedicatedly create a channel schema for that floor also. So now this is what I'm going to do, okay. This is a wrong way. The right way would be this. It won't be a perfect way, but it's going to be still a much better way than what we did earlier. So 3, 4, and let's say building number 5. This is floor number 1. This is 2 again, this is 3 again, this is 4, and this is 5. So this is what I would do. I would do the first floor site survey. I'll say, okay, 1, 6, and 11, 1, 6, and 11. Now the next time I'm gonna put two APs here, design it that well, and make this as 11 and make this as 1. Okay, then again I'll be here doing 1, 6, and 11, and then here I'll do this as 11 and 1 once again. So you get the idea, right? You get the idea. So you also have to anticipate some sort of a bleed between different floors in a building. So when you do a design, when you do a walk on the in the building, just don't cover one floor and replicate that to the rest of the floors. Don't do that mistake. I have done that in the past. That's why I'm telling you the experience. The end result will not be very good for the users on the ground, right? Now also coming to 5 gigahertz, right? When you do a design, I mean, all these things, the right channel schema, the multi-channel use, all these things can be taken care of if you do a right design, right? A right design is very, very essential for these things to work absolutely fine. Now for .11 A and N in an access point, which is going to transmit at 5 gigahertz, 802.11 A and N, this is going to be 5 gigahertz network, right? So we know that, you know, the signal of 5 gigahertz, it's going to attenuate slightly faster, than 2.4 gigahertz signal, right? 5 gigahertz will always attenuate faster. Therefore, when performing a site survey for deploying for dual frequency, always remember this. When you do a site survey to deploy for dual frequencies, design the network for 5 gigahertz first. 2.4 will anyway follow, okay? So when a network is being deployed for dual frequency band, 2.4 and 5 both, always perform the site survey. Let me just make this better. Always perform the site survey on 5 gigahertz, because if 5 gigahertz you're able to cover everything, 2.4 will anyway follow, and the channel schema can be taken care of by RRN anyway, so you're good. Don't make this mistake, guys. I specifically make sure when I'm designing a network, I always design for 5 gigahertz, because 2.4 will always follow and work absolutely fine, right? So that's the importance of a multi-channel architecture. There was also an instance where a single channel architecture was used. I'm not going to spend another video on that. I'm just going to basically tell you there was a single channel architecture also designed long back and was followed by Meru networks. This was around the time when I started my career, 11.5 years back, when Meru networks kind of explored the idea of SCA. There were some good things about that, but there were a lot of bad things about this design. They basically kind of encouraged CCI, and they kind of abolished, you know, the idea of roaming. So for a client, if it's only one coverage cell, so if an access point here is on 2.1 channel number 1 and 1, all of them are on channel number 1. So what happened was, let's say it's like this, everything is on channel number 1. So what SCA does is it virtually creates one big BSS. So what it is going on is, since it's the same frequency, now for a client who's trying to roam between the access point, there is no roaming. The client is just gonna not even think it's roaming, because there is no different frequency allowed here. It's just single frequency band. So yes, they were abolishing the idea of roaming, kind of trying to make it work with some proprietary measures, but an SCA was discontinued and not used anymore. So yeah, that's why I'm not gonna create another video on this, but I just wanted to highlight this in this video, so that you know it's something called a multi-channel architecture, MCA, and it's an SCA also that can be used, but it's now discontinued and not really used anymore. Yeah, thank you. Let's move on to the next video, and yeah, I'll see you there.